Okay, so now what we're going to do is we're going to take a look at stretches and compressions. So the number that's in front here, if you take a look at the transformation rules that I have, that would be an a times f of x is what rule that is. And the rules say that if you have a number in front is between 0 and 1, that means that you're going to have what's referred to as a vertical compression. Now, a vertical compression means that you take the graph and you squish it, press it down like that. If this number is greater than 1, then what you have what's called a vertical stretch. So that means it takes the graph and it stretches it out that way. So the first one we're going to look at is a compression because the number in front is between 0 and 1. You want to start with the base graph. The base graph here is going to be x cubed. So that graph looks something like this. Okay, so that would be your base graph. Now, in order to correctly show this, we're going to put some key points down here for each one. So here's 1, 1, and 2, 8. This comes directly from your library of functions. And then we have -1, -1, and we have -2, -8. That's the original ones. Now, I want to show y equals 1/2 x cubed. What that's going to do, it's going to cut all of the y values in half. Okay, so it's still going to go through 0, 0, but all the values get cut in half. So I'm going to try and show it the same relation as that one. Of course, if you have graph paper, you'll have graph paper provided in the test, so it's going to help you there. Okay, but what will happen is that first point is going to move down to here. This is going to be at 1 and 1/2. We're multiplying all the y values by 1/2. Now, what originally was over here at 2, 8, that's going to get cut in half. So that's going to go down to about right here. So this is going to be at 2, 4. Okay, so 2, 4 is going to be there. Now the other one, we have the other side. That was at -1, -1. It's now going to be at -1 and -1/2. And what was at -2, -8 is now going to be at -2, -4. So that means that's going to be about right here. So that's going to be -2 and -4. Now I'm going to go ahead and draw this for you. And we get a graph like this. So what you can tell here is if you look at this graph and this graph, what we did was we took the graph and we kind of pressed it. We kind of pressed it down or compressed it. So when we compressed it, it actually, you see it's kind of flattening out this part. So that's what the 1/2 does. It actually cut all the y values in half, so it compressed the graph and it looked like this. So next, we're going to take a look at a vertical stretch. Okay, so now we're going to take a look at a stretch. Now, stretches occur when you have a number in front that is greater than 1. Okay, so on this, we're going to take all the y values of the original cube root of x graph, which we'll draw here in a minute, and you're going to multiply all those by 3, and that's going to, in a sense, stretch the graph out and what that'll do. So first, we start with our base graph of cube root of x. You can get this from the library of functions I've been talking about during this section, so the graph looks something like that. Now, the key points here that we have 1, 1, and then we have 8, 2 is the other one. This one down below is -1, -1, and we have -8 and -2. So you want to start with the original coordinates because you need to know those for what the stretch is going to do, because that's really the only way to show that is show what happens to the original ones. Now, what this is going to do, it's going to multiply all the y values by 3. X values stay the same. So originally I did have 1 here, but instead of 1, 1, that point's going to now go up to here. It's going to be at 1, 3. The point 8, 2, that's now going to go up to 8, 6. So now that's going to go up to this point here, so about right there. Down here, this is going to be at -1, -3, because we're multiplying this -1 by 3. And then the other one is -8 and -6. So that's going to be down here. Okay, so that's -8, -6. And this is going to be 8, 6. So notice what's happening in the graph. there's that one. And what we're doing is we're taking the graph and we're doing this. We're stretching it out. So there you can see what that number in front actually does. So this would be your final graph.